Hello and welcome to my presentation. This discussion is based on whether the curriculum as a whole should be cross-curricular or discrete, with links to subjects of maths and science, and whether they should be combined together to create a cross-curricular link, or whether both subjects should be kept discrete, separate. There will be also a link to ICT and the impact ICT has on the curriculum. Firstly, it is important to understand the definition of cross-curricular and discrete. Cross-curricular is different disciplines or subjects that are applied to a theme. Barnes 2007. Yet Hayes 2009 defines the term cross-curricular as integrating subjects to further a child's learning. As well as this, the National Society for Education in Art and Design, no date, suggests a cross-curricular approach is working in an integrated way to explore themes in order to enhance a child's understanding and learning. It can be seen that the definition of cross-curricular has mixed ideas and opinions. Therefore, it can be questioned as to whether we know exactly what is meant by a cross-curricular link, as a misunderstanding of the term could lead to subjects being combined falsely. However, when we look at the definition of discrete, it can be seen that there is a similar viewpoint. For example, Colby and Ward, 1996, suggests discrete subjects are ones which are kept separate and are taught independently. Sanders, 2014, supports this idea and defines discrete teaching as teaching individual subjects alone. Yet, when applying these terms to the classroom, it is important to look at the benefits and disadvantages of general cross-curricular teaching as well as discrete teaching. A successful primary school is one which incorporates two subjects to enhance learning and opportunities. Ofsted 2002. The Ofsted 2002 report showed schools separated curriculum subjects thus making them discrete. This was applied over both key stages. However, teachers made the cross-curricular links. These links not only strengthened the relevance and coherence of the curriculum for pupils, but making sure pupils were transferring and applying past knowledge and experience through to a variety of subjects whilst making good use of longer blocks of time. It is also made successful by the strong links it has with a constructivist view to learning. It is the belief that children who work in a collaborative manner and learn from their own personal experiences develop a successful approach to learning. Hayes 2010. Furthermore, when applying a discrete approach to teaching, the children are learning from one viewpoint. In order to encompass a full understanding, it is important children learn from more than one subject. Carey 2011. However, it can be argued that teaching more than one subject is time-consuming and requires professional development. Jarvis 2009. This is important as not all teachers have had training in how to develop a cross-curricular curriculum and how to create cross-curricular links. And without this, the implementation of a cross-curricular approach will not be as effective. An example of two subjects which are taught together either cross-curricular or discrete is mathematics and science. In mathematics, there are elements and skills which can be transferred in science. Charlesworth and Lynn, 2012. An example of this is measurement. In mathematics, children are taught how to measure in a variety of ways, such as length and height, capacity, mass and time. Department of Education, 2013. Some of these skills can be applied to science. For example, in science, if an investigation is to see how a plant grows under different soil conditions, the children will need to learn how to measure the plant's height. This is incorporating the skills learned in maths and applying it to their science investigation. However, not only does it allow the children to apply what they have already learned, but it provides the teacher with the opportunity to assess the children to see if they have understood how to measure by seeing whether or not they can apply it to their investigation. Fox and Sturtes, 2010. Another example is when using data. In maths, the children will learn how to record data. This can be recording a tally chart, tables, scatter graphs and pictograms, Cross and Board 2014. The children are applying the skills they learn in maths through science, especially when using data loggers. However, the recognition of patterns, data handling and applying it to investigations is key to success in both maths and science. Easingwood and Williams 2003, Ward et al. 2005. Already it can be seen the positive impact maths has on science. Wiese and Gallia 2000 supports this and suggests that science relies heavily on maths and the transference of math skills. Also, maths and science should be cross-curricular, as society is currently dominated by mathematics, technology and science. Students who develop skills in these areas will successfully impact their future. Ferner and Kumar 2007. However, it is argued that maths and science should also be left discrete and not emerge together. Alexander et al. 1992. This is due to the poor links that are made with other subjects or teaching a topic in one subject that has not been covered in the other. This results in a lack of progression being made. Furthermore, if a teacher possesses poor subject knowledge of how children can learn cross-curricular, certain strategies and methods can be counterproductive. Plowden 1967 and Alexander 2010. An example of this was in a recent placement in Year 2. A cross-curricular link of math and science was made. However, the investigation was to record whether an object floats or sinks and to record the results in a table. As the children had not been taught about tables and data, they were not sure how to record the results effectively, and some children had not recorded the results at all. This resulted in the class teachers spending extra time covering the use of tables and data handling, so that the children could understand what was to be asked of them. However, in doing this, the children lost valuable time in carrying out the investigation. In my current placement, maths and science are discrete subjects and are taught individually. However, it is the content within the lessons that create the cross-curricular link. An example of this was made when investigating which animals were herbivores, omnivores or carnivores. In order to do this, we used a Venn diagram which had been used previously in maths. The children were able to identify which section of the Venn diagram animals went by the labels on the diagram. Once this was completed, the application of the science terms was applied. It was explained that animals that solely eat plants are called herbivores, those who eat solely animals are called carnivores, and those who eat both plants and animals are called omnivores. The Venn diagram was completed via the interactive whiteboard to see the children's understanding of whether they could apply their math skills as well as their science skills. The use of the interactive whiteboard allowed children to come up and drag the animal into the right category, whilst the rest of the class were able to see if it had been put in the right place, share their opinions and generate a discussion. The use of an interactive whiteboard and the use of IT as a whole is an effective approach when teaching science as well as other areas of the curriculum, as it has a positive impact on a child's learning. Cox 2006. Further to this, research completed by Harrison et al. 2002 called the National Impact 2 project showed that the use of IT, particularly in math and science, was effective and progression had been made. However, the research in this report is flawed due to the lack of clarity on the nature of the IT resources that were being implemented. Yet despite this, there still seems to be research which strongly supports the use of IT in the classroom to boost children's learning. An example of this is the OECD 2009. The OECD's report showed that 87% of teachers who implemented ICT in learning saw a boost of confidence and motivation in their students. Furthermore, it showed that students' attendance, participation and behaviour had also dramatically improved as a more active learning approach was being implemented. However, it is argued that not all teachers are confident using ICT in the classroom. UNESCO 2011. Therefore, providing professional development courses are needed to build these skills. Yet it is finding the time to fit these courses in with school life. Nevertheless, when ICT is implemented into the classroom, it is ICT that is dominating the teaching rather than the teacher providing the input. Eunice et al. 2013. This is resulting in some children having a lack of understanding. Also, in some cases, more teaching time has been found fixing technical glitches than on teaching itself. Eunice et al. 2013. thus resulting in valuable learning time being lost. It can be seen that although the implementation of ICT is a good opportunity for pupils, as it can hugely impact on the child's learning by providing an interactive approach, it can also be a barrier. To reduce these barriers, it is important that there is a good balance of ICT and teaching time. So in conclusion, it can be seen that the curriculum in general can be separated into set subjects, but what makes them cross-curricular is the content of the subject and the transference of skills from one subject to the other. Focusing on maths and science, it can be seen that these skills from maths, such as measurement and data handling, can be transferred and used in science to help complete investigations. This has been seen done both successfully and unsuccessfully in both my school placements, as what makes them cross-curricular successful is the understanding of the children and the ability to transfer the skills learned and apply them where necessary. It can also be seen that the use of ICT can be effective, and it is important that there is a good balance of ICT and teacher input, as there may be times where misunderstanding has occurred, but with teacher input these can be eradicated. What is most important is that the children are provided with a range of interactive, practical opportunities to enhance their learning.